Hello everyone, welcome back to another episode where we're building a basic game in LÖVE 2D. So I'm really excited because today we're actually going to be adding some gameplay mechanics to our game. So a quick recap on what we did last time. Last time we essentially created different objects for each of our game entities. So quick recap, our entities are our skier, our trees, and our Yeti. And what we did last time, right, is we made each of these entities independent. So our trees have separate timers, have separate behaviors, separate animations. Our skiers all have separate parameters, and that kind of like fixed this problem where you could essentially destroy multiple skiers at the same time. Now you can only eat one at a time. But the greatest thing about kind of implementing separate objects using object-oriented programming is we can essentially start creating independent behaviors for each of our game entities. And so, for example, what we want to do is we want to create an AI system for skiers where, for example, our skiers, instead of kind of going left to right and just crashing into trees or into our Yeti, they actually try to avoid our trees and our Yeti. So they essentially move up or down depending on like what trajectory they are going in. And so what we want them to do is to be able to sense whether or not they're about to collide with our Yeti. And if they sense that they are about to collide with our Yeti or our trees, they essentially change direction. So without further ado, let's get to it. So what we're gonna do, right, is we need to be able to create a way for the Yeti for the skiers to sense whether or not they are going to collide with another object. And so what we need to do is we need to create essentially a way for the skier to see ahead of itself whether or not there's an obstacle. And to do that, we're essentially going to use a sensor. So in LÖVE 2D, using the box2D function, we can essentially create a physics object. And instead of creating a solid collider, what we can do is we can create a sensor. To do that, essentially we use the exact same code that we did for when we created our solid collider for our skiers. But instead of that, we're essentially going to use the set sensor to true on our fixture to create a sensor. So I'm just going to do that right now, just like that. And so now what we've done here is we've created a new fixture, but this fixture, instead of being a solid collider, it's going to be a sensor. To distinguish between our solid collider and our sensor, we're going to kind of separate out our shape and our sensor variables by naming them differently. And then the other thing that we're going to do is instead of doing a rectangle on the same shape where there would overlap, we're going to draw a circle that's much wider or larger than our skier so that he can detect further ahead of himself. So we're going to do a new circle shape, and we're going to give it 100, not 1,000, 100 pixel shape, just like that. And so now if I render this, what you'll see is around our skiers, we have, not a change shape. I need a circle shape. There we go. What you'll see is there's a circle around our skier. And what this circle is actually doing is it's kind of figuring out what other physics objects are inside of it. So right now, for example, you can see it's overlapping with the edge or the corner of this tree, the full body of this tree, and then kind of like the left side of our Yeti. And so what we can do is we can create a callback function to kind of dictate, hey, if this circle overlaps any other body, do X, Y, or Z. And that's what we're actually going to do. So the first thing I actually want to do is I want to draw. Let me pull that back up. First thing we're going to do is we're actually going to draw out those detection. So essentially, we're going to draw a line from the center of gravity of our skier square here to the center of gravity of each of the objects that are being sensed. So there will be a red line between the skier and the Yeti, this tree that's inside of the circle, and then this other tree where the corner is inside of the circle. So to do that, inside of our callback function in our begin contact, we're going to create a new if statement block or if logic gate. We're going to essentially make it so that if it's either the Yeti or the tree that's being sensed by our skier sensor, we're going to essentially add that body that's being sensed to a table of detected bodies. So I'm going to call it other fixtures because this is going to be either our Yeti or our trees. And so if that happens, the skier is going to go to state 4, and we're going to insert into a skier detected bodies table the other fixture's body. So like this, any of the Yeti or tree bodies kind of go inside of that circle we were just looking at, that sensor circle. Then we're going to add all of the data for that body, for either Yeti or the tree's body, into the detected bodies table, and we're going to set the skier to state 4. So now that we've created this table, we need to make sure we initialize it. Since each skier will have their own detected bodies table, we are going to put it inside of our init function here. And then the next thing that we're going to do is we want to draw a red line from the center of gravity of our skier to each of these bodies. So to do that, if the skier is in state 4, essentially there's a body being detected. What we're going to do is we're going to look at each of the bodies inside of that detected body table. And we are going to draw a line between the skier X and Y and the bodies, the detected bodies X and Y. Just like this. And then I said I was going to draw a red line, so I do need to call love.graphics set color 100, and then I do need to put an end statement, and then we are going to reset it, because if not, we're going to draw the whole screen as red, just like that. Boom. And so now, when our Yeti goes in the circle, nothing happens. Why does nothing happen? Self state. Bodies get X, get Y. What happened? Skier body, get body. Oh, the other fixture needs to not be equal to the skier sensor user data. It needs to be either the skier or the Yeti or the tree. There you go. So now you've got this red line. We have a problem where the line doesn't disappear, and that's because we essentially need to bring all of this code block inside of our end contact. And here we're essentially going to remove from our detected bodies, and we're going to set our skier state to state 1. And so now when our Yeti goes into the circle, there's a line. When the Yeti goes out of the circle, there's no more line. But there is another problem. So like right now our skier detects our tree, and so it's drawing the line correctly. When the Yeti goes in, it's detecting the Yeti correctly. When the Yeti collides, like that square touches the square of the skier, all of the lines disappear and they don't come back. And then when the Yeti leaves the circle and comes back, then the line for the trees and the Yeti come back. The Yeti leaves again, and now only the Yeti line is here. So what's going on with that? So a couple things. Essentially, there's multiple collisions happening at the same time. When the Yeti or the tree overlap the circle, it sets the skier to state 4. And as long as they overlap, it's setting the skier to state 4. And this is true until the Yeti square touches the skier square. When that happens, the skier state actually changes from state 4 to state 2. Because when that collision between the two squares happens, even though the sensor collision is still going on, this is the code block that's run. So we have a problem where essentially our skier state is being overridden depending on the order of which the collision is taking place. The other problem is every time the Yeti leaves the circle, we're removing one of the bodies from the detect bodies, but we're removing the first entry in that table. The first entry is going to be either the Yeti or the table. We're not actually telling it which entry to remove from the table, so we need to identify which body we want to remove from that table. So let's fix this first, and then we'll fix our problem with the skier states being overridden. So to do that, what we're going to do is we're going to check all of the detected bodies, and we're going to find which one we need to remove. So for J bodies, inside of pairs of skier detect bodies, what we're going to do is if other fixture get body is equal to bodies, then we want to remove the jth entry, just like that. And so like this, essentially, it's going to remove the correct one. So if the Yeti leaves, it's removing the Yeti entry, or the Yeti body from the detect bodies, it's not removing the trees. So if we check that implementation, let's get that second skier to come and collide with that tree. Perfect. And so now the Yeti goes in, the Yeti leaves. Did I not? Oh, maybe I did not save. Oh, yeah, I did not save it. Oops. Okay, so our tree, okay, our skier is going to collide with those trees. And so you can't really see it, but there's two lines. There's one line here and then another line here. When the Yeti goes in, we got our third line. Yeti leaves. Only the Yeti line disappears, not the tree ones. So that works. The problem is we didn't fix the collision. So if the two squares collide, all of the lines disappear until the Yeti comes back in. So to do that, essentially we need to remove the skier states from our callback functions. And our callback functions, like, because of the order in which they're run, it's actually pretty important, and we don't actually want to change the state of the skiers directly in them because it creates issues that are really hard to debug. And so what we can do is we can actually kind of remember what the meaning behind being in state 2 or 1 or 4 or whatever is actually what that definition is. So skier in state 2, essentially what that means is that the skier is in a position where it can be eaten by the Yeti. It doesn't mean that it's been eaten by the Yeti. It just means that if you press the return key, the Yeti will eat the skier. But if you don't press the return key, nothing happens. So instead of changing the skier to state 2, what we could do is we could just track the skier in a separate table. And all of the skiers that are in that separate table have the possibility of being eaten if we press the return key. And that's a different way than kind of just changing the state inside of our callback function. So what we're going to do is we're going to actually do that. So I'm going to do table.insert, and we're going to call it skier destroy. So this is going to be a table where we're going to keep track of whether or not a skier can be destroyed, just like that. And then similarly, if the skier cannot the contact between the two squares of the skiers is gone, we're going to remove the skier from our skier destroy table, just like that. In this case, the collision between the skier and a Yeti is unique, so we can use just one. So now that we've created a skier destroy table, we need to make sure that we call it in our dependency. Actually, we do have it here already. It's perfect. And so if we go back to our little code block here, which is where we manage whether or not a skier is destroyed, we actually need to change this because we no longer have a skier of state 2. We have a destroy table, a skier destroy table. So we're going to call skier destroy. So for all of our for each skier inside of this table, if the return key is pressed and our Yeti is in state 1, what we're going to do is we are going to destroy the skier. So we're going to do skier.body destroy. And then essentially what we do, right, if we destroy the skier body, we want to make sure it's no longer rendered to the screen. The way to not make it rendered to the screen is if we remove it from our skier table. So we're going to do an if statement. So if, we're going to check for each of the skiers in skier table if they've been destroyed. If they've been destroyed, then we're going to remove them from the table. So for J skier in pairs skier table, if the skier body is destroyed, then we will remove that skier from our skier table, just like this. And then we need to make sure we put an end statement, just like that. Just to not confuse things, I'm going to change this to skier flag, because we're referring to the skier twice. And then once we've destroyed our skier, we want to reset our skier destroy table. If not, it's always going to have a value. So it's always going to have a skier in it. So we're going to do skier equals this empty table here. Perfect. So now if we render this, let's let the skier crash into the tree. So it's detecting all of our trees. It's not detecting our Yeti. When the Yeti collides with the skier, the lines stay in because we're no longer changing the skier state to state 2. The Yeti leaves, and so our skier's figuring out everything is correct. Let's see. But I am no longer able to destroy the skier for some reason. Let me see what's going on. So I was pressing the return key and that wasn't doing anything. Oh, I need to not remove I, I need to remove J. So if I remove I here, it's actually removing the ith skier in destroy our skier destroy table. But we want to remove from our skier table. This is all of our skiers. This is only the ones that can be destroyed. So we need to make sure I was removing the right skier. So let's try that again. So our skier is going to go, collide, boom. Our detections are working correctly. Collision's happening, and boom, we're eating our skier. Perfect. So now that we've got all of that fixed, what we're going to do is we're going to implement our skier AI. So for our skier AI, I just want to draw it out really quick what we want to do, just to kind of get on the same page. So let's say this is our skier. Let me draw a quick square. Boom. Well, it's not a square, it's a rectangle. But let's say this is our skier, and then this is our tree. It's a larger rectangle. What we want to do is so we're going to look at the center of gravity. So this is the center of gravity of our skier, and this is the center of gravity of our tree. If the center of gravity are aligned, right, then that means that they have the same y. So if this line is, if this is the same line, then that means that our skier is going to crash into our tree. And actually, it's not so much like the center of gravity is if it's this point and this point is at all overlapping between this point and this point, this bottom point, then you're going to have a collision. So what we need to do is we need to essentially move either our skier up above this point like this, or down below this point. And so like this top right point is below this bottom left point of our tree, or this bottom right point of our skier is above this top left point of our tree. So what we're going to do essentially is we need to calculate. So let me clean all of this up. What we need to do is we need to calculate this distance and this distance and this distance and this distance, and we need to make sure that this distance is above this point here is above this point, and then or this point is below this point. All right, hopefully that made sense to like what we're gonna be doing. All right, so to do that, we're gonna loop through all of our skiers. So for I skiers in pairs of skier table do, and then I'm going to put an end statement here. So first thing we're going to do is we're going to check if the skier is not destroyed. So if not, skier.body is destroyed. All right, we want to make sure that we're not using a skier that doesn't exist anymore. And then, our skiers are in state 4. So we're going to do skier state is equal to 4. So if both of these are true, then what we want to do is we want to compare the x and y values of the y value of our skier to our y values of the detected bodies. So for I'm going to call it actually j bodies in pairs of skier dot detected bodies. And so what we need to do, right, is we need to make sure that the distance. So let's draw it back really quick. So let's say this is our. Let me undo. This is our skier, and then this is our tree. We want to make sure that the delta between the y value here and then the y value here is bigger than the distance of the half of the height of our skier and plus half of the height of our tree. So essentially, we need to do the absolute distance between our bodies get y minus our skier y. So if this distance is less than half of the width of half of the height of our skier and half of the height of our tree. So our tree is 50 and our skier is 25. So we do 12.5. This is half of the height of our skier, and then 25, which is half of the width of our tree. Then what we want to do is if our skier y value is higher or is a smaller y value, that means it's above the center of gravity of our tree, then we want to move our skier up. If the y value is below the center of gravity of our tree, then we want to move our skier down. So if bodies get y minus skier y is negative, that means that our skier y is bigger than our objects or the detected bodies, then we want the skier to go down. Then we're going to create a movement, and we want the y value to get bigger, so this is going to be positive. Else, that essentially means that the skier y is smaller than the body's y value, and so we want the skier to move up. So we're going to do move is equal to negative skier move. Oops. Perfect. And so now what we're going to do is we're going to change the velocity of our skier. So set linear velocity. And so now we have we have our x movement that stays the same, but now we also have a y adjustment with move. All right, let me put all of the end statements, and let's test it out. So now if I summon the skier and it detects the Yeti, now you see it's moving up. It's like, no, I don't want to hit the Yeti. I don't want to hit the tree. I'm moving, and they're moving. It's like a little bit rough. Maybe we're going to give it a little bit more leeway. So instead of 25, let's do 35. And so now it should maybe be a little bit smoother. Yep. There we go. And so now our skiers are actually actively trying to avoid our trees and our Yeti. I mean, they kind of get stuck because it's not perfect, but 35 is maybe a little bit too big. Let's do 30. Yep. Now they're trying to avoid the obstacles, which is kind of cool. There you go. And so what we've done essentially is create I guess our skier AI. It's a little bit messy, right? Because we're still managing skier states. All of this code should probably be packaged in our skier class. So it should be a function here instead of just a for loop inside of our main. Same thing with our remove or destroy skiers. And then the big problem is really like our callback functions. Essentially, we just keep adding these logic gates, which is not really manageable. Maybe we should essentially create a more generalized callback function to make it more scalable. But our game is really taking shape. So now we have kind of like smart skiers, and they're trying to actively run away from the Yeti. They're not really good at running away from the Yeti yet. But if I made, for example, if I made the Yeti square a little bit smaller, it'd actually be a little bit more difficult to catch these skiers because now they're actually trying to run away from you a little bit more efficiently. But yeah, so our game is really coming together, and this was really cool. So again, thanks so much for watching, and hopefully this was helpful or valuable for you. Super excited to kind of keep going with this game. And again, if you like what you're seeing, please like and subscribe. And yeah, if you have any suggestions or ideas that you'd like to see implemented in here, just feel free to leave a comment. All right, thank you so much.